Hello and welcome to my video for assignment 1. My name is Elise Franchuk, and if you're wondering about my introduction, you can click the video right there. I'll link it to the previous one. So today we're going to be covering the unit overviews and exercises for this assignment. First thing I'd like to start off is defining a robot. But basically, in essence, a robot is an autonomous system that is physical. So this is different from AI or a program. It could be all of that, but mainly it's something that is acting by itself in the physical world. So basically, it needs to have three things: the autonomy, action, and it must also have a physical goal. In order to talk about robotics, we need to cover an important theory. It's called control theory. This is the mathematical studies of control systems. This is one of the foundations of engineering. Robots, they come from control theory, cybernetics, and AI, but no, not one of them is just robotics. So, connection types. There is excitatory connection. This is a connection between sensors and a motor that, upon strong stimuli, cause the motor to increase power. There is inhibitory connection, basically does the opposite, it decreases power when there is strong stimuli. And there is photophilic and photophobic, basically light sensors. You can program them depending if you want them to react to light. They can do certain things. These are all examples of it. However, there's a lot more types of connections and sensors. It all depends on the goal of the autonomous system. It must act on the set of sensors and stimuli. So some of the components are physical vectors, actuators, and the controllers. We have a rough idea of what they do, but another important concept is awareness. So for example, do the sensors do they read fixed data points, such as it is true or false, or is it variable, such as we're going 12.3 kilometers per second or hour? Per second would be very fast. Then there's external and internal states. This is what the environment state is, what is the structural integrity, what are the battery levels, position relative to the environment. And actually on that point, when it's relating itself to the environment, this is called representation. And honestly, this is very important because depending on how fast the robot can react to environmental change, it kind of depends on what the robot's what its purpose is. So robotics, it's concerned with two main areas, locomotion and manipulation. Locomotion, that's when it's moving through land, air, and water. Manipulation, that's more manipulating the environment. Think of robotic arms. Both fields, they're concerned with degrees of freedom. So when someone's talking about degrees of freedom, they're talking about how much mobility a robot has. So for the exercises, circuit 1A was just a blinking light. I covered this in my last video, so I'm not going to document it. However, it was a very basic circuit. Circuit 1B, the potentiometer. This is using an input device to control the speed of LED blinks. Analog signals are introduced in this exercise. Basically, digital signals can be on or off, while analog signals can be variable. So when we talked about it being true or false, or how fast we're going, this is what we're talking about now. So potentiometers can be used to split voltages to lesser levels. If you're familiar with Zener diodes, these components are used in voltage regulators. Transistors, on the other hand, they raise the voltage levels. That's why they're called amplifiers. So it's important to mention that potentiometers, they're not polarized. A diode has an anode and the cathode electrodes. Electrons run from the cathode to the anode and run only in one direction. So potentiometers can be wired in any direction, but the current will be reversed if they're swapped. So the programming of the potentiometer. Basically, we can change on-off intervals between the blinking light with the potentiometer. As we can see here in the code, if the potentiometer is turned up the voltage, it can change the delay between each blink. So in the next exercise, we went over photoresistors. Using light as stimulus, as I mentioned before, this would be the excitatory or inhibitory connections. The photoresistor can be used to make a circuit respond in the presence or absence of light. But using a very basic if-else logic, we can program an LED to emit when there's no light. So at this point, I think it would be important to go over debugging and how serial communication works. So serial communication sends information from the Arduino, from the analog pin directly to the computer or interfacing device. But it could send the signal from any pin. So this communication uses baud rate as a measurement when sending signals. This is calculated how many symbols per second it can send. The standard baud rate in most microcontrollers and remote terminals is 9600 and so on. If you've ever used PuTTY, you'll be familiar with this concept. In this case, we can see what the sensors or components are picking up. It could be very useful for when debugging things. So as you can see in this screenshot here, where there is lower light levels, that's where less light is when I turned off the lamp. Alright, so a new section is added in the code to interface with the terminal. As we can see on the right-hand side, we have to begin the serial communication at the baud rate. The photoresistor sends the analog information to the A0 pin. This is then used to print the values. In the loop function, the photoresistor variable is compared to a static integer. If it is smaller than that value, it means there's less light. I sort of measured it out. I found out 500 to be the arbitrary value. So if it is bigger than that, it jumps into the else statement and turns the LED off, or vice versa. So the next exercise was the RGB nightlight using the photoresistor but with RGB LED and potentiometer. It was very similar to the last exercise, but when the light was not detected, it could use the potentiometer to change the colors. Pulse width modulation is a concept when the average electricity is reduced. In the RGB LED, when this happens, it changes the frequency of the light. When you change the frequency of to something lower, it'll be a lower color. When you change it to higher, it'll be a higher one. If we were to use an oscilloscope, we could see the frequency of the wavelengths decrease. This is called duty cycles. If the duty cycle is at 100%, the power is at 100%. In the normal LED, the lower this duty cycle, the dimmer the LED would be. So the programming, most of the code was the same except for adding the values to the RGB more conveniently. Lastly, the main logic for switching colors is the else-if statements. On to Module 2 exercises. We have the buzzer. So the piezo buzzer is a small magnetic coil that can vibrate at different frequencies. This component is polarized, unlike the potentiometer. The different frequencies can be stored in variables and then called from an array. The tempo and beat can also be applied this way. I found an existing piece of code on GitHub that plays an iconic tune. It's linked right there. The second part of this exercise is the potentiometer that acts like the volume dial by decreasing and increasing its voltage levels. The next exercise is the digital trumpet. Buttons are added into the circuit. The code here is an else if logic statement. When there's any inputs from the digital pins, it tells the buttons to play a corresponding frequency to the buttons pressed. A 330 ohm resistor was added to the final product to reduce the chances of burning the Arduino pin. This was the last exercise for the module, and this was the Simon Says game. This was the hardest project so far, because of the limitation of the breadboard and because I wanted to include a 1-digit 7-segment display. So I used 3 separate boards to put everything together. It was quite a challenge to put all the resistors in place because every resistor needed to have its own wire for the ground and for the control wire. Mostly everything is the same as the previous project. This is just everything combined. Obviously the noticeable difference is the 7-segment display. I could have just used a serial monitor to display the score, however I wanted to be more visual. This created a problem of not having enough digital pins. I found out that the analog pins can be used as additional pins, but you'd have to start from 14 to 19. So if there was no pins left, I would need to get these 2 components to increase the pin. Right here, these are the player picked values, and these ones are the machine picked values, and we'll use the random function for these guys. In the beginning we initialize everything we need to, LEDs including the buttons. We set some variables, when to start counting, the score, so on, even and the baud rate for debugging. Then right here we just have the game running. Every time you press a key, button, it then adds a number to one of the variables. And this is how it works here. Basically if it's 1, it's going to equal the number pressed. Then 2, this is the incrementing variable here. On the 4th try, basically it then compares the values to the machine picked values, and we can see here for the debugging you can pick, it prints the checking combination, and then it says x to 1 to start from the beginning, and that's the debugging I used. For the level here, if 1 is equal to the random 1, 2 is equal to the random 2, all of them, it goes into here, goes into this if statement, else it says it's incorrect. It shows the challenge, which gets it to pick another random set of numbers, and also sets the score to 0. However, if it's 10, it'll play the winning tune and print correct. not 10, it'll just continue creating new challenges. This function here is for showing the light but not recording it, so when the Arduino starts showing you the sequence, this is what's happening right here. As you can see, the add number function is removed from each one. Lastly, we have the numbers function, and here we set the segments to be whatever the number is, and there's 10 in total, each one being linked to a specific number. Now the last part of this code is from GitHub. It's keyboard. All right. Alright, so that brings me to the end of the video. Thank you for watching, and next video will be on assignment 2.